Worked example 9, identifying series and parallel elements of a circuit. Alright, in question 1, we're asked to identify how each resistor is arranged, whether it's in a series or in parallel in the following circuit. And the following circuit has got our 3 resistors, probably the most basic combination circuit that you can get. We've got our 3 resistors connected like this, and we've got R1, R2 and R3. So the first piece of advice I would give is when you're fresh to this, or you may be coming back after a bit of time away from doing this kind of stuff, get into the habit of drawing out the circuit initially and actually labelling it up. And one of the other things I would suggest is getting pens, colouring pens, some colouring pencils, whatever, to actually highlight the different branches, because it really does make it a bit easier to try and follow what's going on and identifying it. After a while, once you've done that, eventually you'll be able to just start recognising which elements are in parallel, which elements are in series, and how it all comes together. But if you don't put that initial work in, it will always kind of be a bit of a mystery. First of all, identify all the parts in the circuit where there's effectively 3 or more connections. What I mean by 3 or more is, if you think about like a corner, that's not really a connection, but if you wanted to think of it as a connection, just for an example, then you've got a wire coming in, a wire coming out. So that'd be like 1 wire and then 2 wires, so it's not 3 or more. Whereas if we go to a section like this, where the wire is splitting, so 1 wire coming in, another wire coming out, and the 3rd wire coming out, then that's 3 or more, and we would call that a node. And because you can get more than 1 node in the circuit, we would call that node 1, for example. And then if we go around the rest of the circuit, we can see there's another node here where there's 3 connections, 1, 2 and 3. So we could call that node 2. Okay, so we've got these 2 nodes. Now the reason we want to do this is because this is going to help us, following some of our rules, identify when stuff is in series and when it's in parallel. Now, the very basic rule that we can follow is that when we've got multiple components on a single branch, and a branch is anything that goes from a node to a node, then those components are going to be in series. And it's a bit like if you imagine like a pearl necklace, where you've got all the pearls connected. So the string goes through all of them. So all the pearls are in series because they're all in the same bit of string or on the same branch. So for example, we've got our battery supply here, and it goes from node 2, it's connected on this branch that goes from 2 all the way around to 1. So the battery and the resistor 1 here are in series with each other because they're on the same branch, right? However, if we look at these other branches here, which we'll highlight in a second, we can see that we're going from node 1 to node 2 on this branch, and we're going from node 1 to node 2 on this other branch. Now, because these branches share the same start and finish points, the same start and finish nodes, then these 2 branches are in parallel. And any group of resistors or components on these branches would be in parallel with each other. So that R2 and R3 are in parallel with each other. But this whole section of the circuit is in series with R1 and in series with the battery. So let's highlight some branches now just to see how that can help. Now if we come out of node 2 and go all the way around, this branch, this green line here, represents a single branch, and as you can see on that branch is the battery and resistor 1. So the battery is in series with resistor 1 here. But when we get to node 2, we can see that we've got 2 options, we've got 2 paths to join node 1 and 2, and that's this top path, which I'll highlight in red. So we've got the red branch, and then below that we'll have a gold branch going from node 1 to node. The 2 branches, the red and the gold, both start at node 1, both finish at node 2. So those 2 branches are in parallel, and that tells us that R2 and R3 are in parallel with each other. So the way I would write this out is I would say that R2 and R3 are in parallel, and the combination, or the parallel, is in series with R1. Question 2. Question 2 is a slightly more complicated circuit once again. And again, we'll draw a little sketch of our circuit here. What I'm going to do again is I'm going to highlight the branches. So remember, 3 or more connections. So node 1, node 2, through resistor 3 down to node. And likewise, we've got the other route, so we can go from node 1 through R2, through R4, and up to node 2. And then lastly, we've got this branch that goes around all the way around the outside, through the battery, through R1, and back to node 1. So there are 3 branches on this network, and we've got the red branch, the green branch, and the gold branch. Now, if we look at what's going on here, only the red branch and the green branch share nodes 1 and 2. Technically, the gold branch also shares nodes 1 and 2, but we're not going to get into that. What we are going to talk about, though, is the fact that red and green share the same start and end node. That means that our R3 is in parallel with R2 and R4. Okay. Now, the bit that students often get confused about, they think is it R3 and R2? Is it R3 and R4? No. Remember, because R2 and R4 are now in series on the same branch, they are in series with each other, and we would have to add them together, and we would have to treat the total resistance of the green branch in parallel with the total resistance of the red branch. So if we were to simplify that down in terms of a sketch, it would look a bit like this, where we take R2 and R4 together into a single resistance by adding them because they're in series, and that would be in parallel with R3 like this. So we would simplify the green branch down, R2 plus R4 to get a single resistance, and then that resistance would be in parallel with R3, and then that combination in parallel would be in series with R1. This whole combination in series with R1.